Hi ladies and gentlemen, this is the lesson on similarity in measurements, lesson 6.5. You'll find this is a pretty simple lesson. It's building right off everything we've been doing, and it'll go pretty quickly. So let's go ahead and start with the first slide. As I'm pulling that up, make sure that you're taking notes. You're looking for the learning target. Why are you trying to learn this? What is it that I'm expecting you to be able to do afterwards? Not necessarily have mastered, but be able to start to work on this kind of problem. Again, write down examples, any keywords that you hear or see, and questions as you need to. And also rewind, fast forward, and pause as you need to with this video. Okay, this first slide is finding an unknown side length in similar figures, and we're given two rectangles, KLMN, and we're told it's similar to PQRS, and we're asked to find SR. So let's see. We need to find SR, and that would be this line segment right here. So I'm going to just place an X here for right now because I don't know that measurement. And then I need to start to set it up as proportions. So I see that KN is one of my short sides and PS is one of my short sides. So I put those two over together. And then I look at my smaller triangle, and then I'm putting that over top of my larger triangle. So I'm going to be placing my smaller measurements over top of my larger measurements, and that's supposed to be an L. So bear with me and pretend it looks like one. So at this point, I'm going to substitute in the numeric values for my known measurements. I know the measurement for KN is 2, and I know the measurement for PS is 3 centimeters. And I'm going to set that up as a proportion and to my long sides. So 3, because I'm putting my smaller ones on top, and then my larger one is X. I don't know that side length yet. So now I'm trying to figure out how do I want to go about solving this. I can either cross multiply and end up with 9 equals 2x, or I can say, well, how did I go from 2 to 3? And you might say, oh, well, that's multiplied by 1.5. So if I'm doing 3 times 3 and get 9 for cross multiplication is equal to 2x, I'm asking basically what is half of 9, and that would be 4.5 centimeters, since we're talking in centimeters. But again, I could also say, you know what, 2 times 1.5 would give me 3, 3 times 1.5 would give me x, and these are just two possible solution paths to find out that x does in fact equal 4.5 centimeters. So go ahead and copy down any of these notes that you need to. Pause if you need to, because I'm going to erase this page, and then I'm going to move to the next. Okay, ladies and gentlemen, so now we want to talk about using indirect measurements. This can be good when something's not a very easily measured item, but we know some given information. So sometimes telephone poles or trees we may not be able to truly measure, but by using information that we can measure, we might be able to find that unknown length. In this case, we're pretending ostriches, maybe this is the boy ostrich and he wasn't as easy to catch to measure, and maybe the female was easier. So the shadow cast by a 4-foot female ostrich is 10 foot. The female ostrich, 4 foot, is casting a 10-foot shadow. And it says a male ostrich is standing nearby and casts a shadow that is 15 feet long. How tall is this male ostrich? So he's casting a shadow 15 feet, but we don't know how long he is. So we're going to do the proportions, and then we're going to solve. And let's just say that we're going to take the larger ostrich, so the male, but I'm going to put larger, and we're going to place it over the smaller. And it really doesn't matter, I could do it either way. I just happen to know this way my x will be on top, but it doesn't have to be in the numerator. I'm just choosing to go ahead and leave it that way. So if I take my larger measurements, the tall or the height of the ostrich is x for the larger one over 4 for the female. And then I'm looking for my shadows and I'm setting up my proportions. Again, looking at the larger one to go on top, which I know is 15 feet. And I'm going to be placing that over the smaller shadow, or the smaller ostrich's shadow, which is 10 feet. Now I have to think about how did I get from 4 to 10? Some of you might instantly know, but if you don't, I can cross multiply. 4 times 15 is going to give me 60. 10 times x gives me 10x. Well, what is 6? I kind of just gave the answer. What does 60 equal to 10x? What does x have to be? X does need to be 60. If you didn't see it right away, you could have still divided both sides by 10 since 10 is being multiplied to x. Again, you might have seen that this 4 times 2.5 immediately gave you 10. Then you can say, well, what is 15 divided by 2.5 going to give me? Because if I take 10 divided by 2.5, it's 4. There's many ways we could go about solving this. Again, this is just two very common ways of doing it. Feel free to go ahead and take any of the notes that you need to, pausing at this time if you need to, because I'm going to be erasing this writing, and then go ahead and continue when you're ready. And I'm clicking. Okay, there it goes. So the next one is using our algebra and similar triangles knowledge. So we're given that triangle BAC is similar to triangle ECD. So let's just do a quick look. BCA, that is going to be this larger triangle, or the outside triangle. And then triangle ECD is the smaller triangle inset into the larger one. So I need to do a couple things. I need to set up proportions. And look at that, I'm already kind of just pre-filling, right? Because I know I need to do that. Let's do the inset triangle over the outside triangle. So I'll give myself a reminder of how I'm doing this. I'm making that a capital I so I can tell inside versus outside. Please know that that's, and I'm going to put a little U so I know that that's an outside, not just a 0 or something crazy. So let's look at my insides here. I can see that this and this is going to be similar, and I have 7 and I have x. I said I'm putting the inside on top, and then I said I was going to put the outside on the bottom. Then I'm going to come over here and say, okay, from here all the way here is 30. That is my outside one, so that needs to go into the bottom. And then I need to find my inside triangle's measurement. Right there is 15. And then I need to decide how do I go between these. So ladies and gentlemen, some of you might be like, wait, I can set up a proportions. I can make one more proportion. 15 goes into 30 one time, sorry, 2 times. And if I divide by 15, I get 1. If I divide by 30, I get 2. So my ratio simplifies to 1/2. Well, if that's the case, and this is 7, what would x be? If I tell you this is also, that's right, I'd be multiplying this both by 7, so that x would become 14. That is a third way that we've talked about in this little video session of how to find. Again, I could have easily gone back to my original here and said I can cross multiply 210 equals 15x, divide 210 by 15, I'd get 14. I could say, what do I do to 7 to get 15? Or I could take 15 divided by 7 and then know what I need to divide 30 by, and I should still get 14. There are multiple ways. Now, I know I'm going to heartbreak some of you, but if you need to take these notes, please go ahead and pause the video. I'm going to be cleaning this slide, and that was the last slide of this little video. So thank you for your time.